Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to improve our math skill. Today is our day number 25. Day number 25. Let's see what we have for today. Mike drives to work at an average speed of 50 miles per hour. He returns home along the same route at an average speed of 40 miles per hour. So we are told that on the way to work he averages 50 miles an hour. On the way back along the same route, he doesn't change his route on the return journey. On the way back he drives at an average speed of 40 miles an hour. So far so good. He spends a total of 90 minutes driving back and forth to work. The question simply is, how far does this poor guy work? He ends up driving 90 miles, commuting 90 miles back and forth every day, which is not a poor guy, because I know people who drive 90 minutes per way, each directions, in the morning and in the evening, in the horrendous traffic, in the rush hour traffic. Very stressful. So hour and a half actually is, anyway, I'm just babbling. Question simply is, how far does he work? Again, as always, what I want you to do is pause the video at this point, solve the problem yourself. If you have trouble solving it, you can seek somebody's help, you can ask your friends. You trust me, you will learn more that way. Just by talking and working together, you will improve your math skill. Do whatever it is that you have to do. Solve the problem. Once you have the solution, then you can resume the video. I'm going to give you a few seconds to pause the video and resume and so forth, and I'm going to be out of the frame for about 5 seconds. How far does he work? That's the question. Well, let's see. So here's the situation. Where is his home? And here's the work. Why is it I can't spell anything? Going that way, he goes 50 miles per hour, and if you don't like 50 miles per hour, you can change that to 50 kilometers per hour. I could care less. It doesn't matter. It is immaterial. The unit is immaterial. On the way back, he goes 40 miles per hour, and he ends up driving 90 minutes back and forth. How far does he work? Let's start the solution, shall we? Now, in order to solve this question, I could actually start the solution down here, but it gets too crowded, it gets too low, I don't like it. I'm going to actually erase the problem. You know what the problem is, and of course if you need to look at it again, you can always rewind the video and watch it again. Okay? So I'm going to read the problem one more time and then I'm going to erase it. Mike drives there. Mike drives to work at an average speed of 50 miles an hour. Returns home along the same route at an average speed of 40 miles an hour. Okay, don't worry about the chopstick I'm holding. I'm very proud of it. I've been rehearsing, I've been practicing in front of the mirror for the last 3 days for this moment. So here we go. He spends a total of 90 minutes driving back and forth to work. How far does he work? That's all it is. Let's solve it. We know that he spends total of 90 minutes driving. 90 minutes is hour and a half. 1.5 hours. Let's pretend that he goes 50 miles an hour for T hours. Let's pretend that he goes 50 miles an hour for T hours. T I just used for time. If that were the case, then he must, this would imply, if that were the case, then he must drive 40 miles an hour for how many hours? No, we can't create another variable. Mathematics is, algebra is a language, and just like any other language, the symbols have purpose, symbols have meanings. We cannot create another symbol. If you were to create another symbol here, let's say STQ, if you were to create another symbol here, then what you're telling me is that there's absolutely no relationship between this amount of time that he spends going at 50 miles an hour and the amount of time that he spends going at 40 miles an hour. If you were to create another symbol, what you will claim is that these two number of hours have absolutely no bearing on each other, which of course is not true. If guy is driving an hour this way, and if he spends total of 1.5 hour, then he must be driving half an hour that way. If guy is spending 45 minutes going this way, then he must spend 45 minutes going this way. If the guy is spending 20 minutes going this way, then he must spend 70 minutes going this way. You get the idea. They are related. How do we find it? One more time. You see? I'm going to do it one more time, all of that thing again. If he spends, let's pretend that he spends an hour going this way, 1 hour. Then how much does he spend going this way? Half an hour. Where did we get that? We got that from this one. Our total amount of driving time that he has is 1.5 hours. And if he spends an hour, then this must be the time that he spends going this way. Now let's do one more problem in a different color so you can see it. If he spends going this way, if he spends what should we put here? I forgot the example that I put there before. Let's say 3/4 of an hour. And how much time does he spend going this way? Must be 1.5 hours minus 3/4. Where did 1.5 hours come from? That's his total time. So the amount of time that he spends on the round trip is the total amount of time that he spends. The amount of time that he spends on the way back, the amount of time that he spends at 40 miles an hour is the total amount of time that he spends driving back and forth minus the amount of time that he spends going to the work. While going to the work, he spends T hours. So he must spend whatever is left over from 1.5 hours. 1.5 minus the T hour. Voila. 1.5, hour and a half minus whatever he used up on this speed. If he spent T hours, whatever the T happens to be, we do not know, whatever amount of time, I'm saying it one more time, whatever amount of the time that he spends going from home to work, the amount of time that he spends driving from work to home must be 1.5 minus the time that he spent already in the morning. So altogether it's hour and a half. You understand? So if it's T hours, then this must be 1.5 minus the T. Minus T. That is the biggest hurdle for most people coming up with this concept. That's why I'm taking so much time to explain to you. Okay? Now, let's continue our solution. And at the very end, I'm going to actually explain one more time, just to make sure that you're with me. Now we know that distance has to equal speed times the time. This is unrelated. For example, if I'm going 30 miles per hour for 3 hours, how far would I go at 30 miles an hour at 3 hours? 90 miles. And where did I get 90 miles from? From here. 30 miles per hour times 3 hours. Hours cancel out. And you end up with 30 times 3, which is 90 miles. Right there. That's the formula. Well, I shouldn't actually call it formula, but because when you use the word formula, it sounds like something geeky, something nerdy, something that you have to simply memorize. Well, it is a formula, but it's your everyday life. There's nothing good. Don't go around calling it formula, because it's everyday life. That's what we do. If I travel for 5 hours at 20 miles per hour, how far do you suppose I would go for 5 miles? I would go 100 miles. Right here. 20 times 5. Distance equals speed times time. So we're going to use this concept, and therefore the amount of distance from A to B has to equal 50 times T, or to be more precise, it has to equal 50 miles per hour times T hour. And that distance has to be same as the distance from B to A. Distance from B to A. Why does the distance has to be the same? Because that's what we are told in the problem. We are told that he takes the exact same route. He doesn't take a detour, he doesn't take a different route, he takes the exact same route. So the distance from A to B has to be the same from distance from B to A. The road is not going to shrink on his way back, nor is it going to expand. And how do you find this distance? This distance is going to be, on the way back, is going 40 miles an hour. So 40 miles per hour times the amount of time that he spends at that speed, which is 1 minus T hour. Let me erase this part now so that it does not get too confusing. Let's simplify, shall we? So you can see this hour cancels out with this hour. We end up with 50 times T miles. 50 times T miles, which has to be same as this hour cancels out with this hour. 40 times 1 minus T miles. Now all we have to do is solve for T. Solve for T. So this becomes 40 minus 40T. Bring the 40 on this side, so we end up with 10T equals 40. Something has gone drastically wrong here. Let's see. It's not 1 minus T. It's not 1 minus T. The amount of time that is spent. It would have been 1 minus T if he had taken a total of 1 hour for the round trip. He takes a total of 1.5 hours. So the amount of time that he spends driving from B to A, time that he takes driving from B to A is hour and a half minus the time he used up driving from A to B. I should not have called them A to B because I should have called them from H to W, from home to work, and from work to home. As a matter of fact, we can still change them. Let's not call them A to B. Always use your symbol in a way that makes it easier to remember what is what. From home to work, and from work to home. The time he takes driving from home to work, or rather, the times that he takes driving from work to home in the evening is 1.5 hours that he takes the total amount of time, minus the time he already used up in the morning driving from home to work. And that is 1.5 minus the amount of time he took in the morning. This should have been 1.5. Minus the t. So 40 times 1.5 is 60 times 40 times 1.5 is 60, and then 40t. Bring the 40t here, so you end up with 10t equals 60. Oh, this should not be 10t because when I bring the 40t here, let's do it properly. This is 50t. Let's add 40t to both sides. So here we end up with 90t equals 60, and t equals 60 over 90, or 2/3 of an hour. Voila. So now we know how much it takes, how long it takes him to drive from home to work. From home to work, it takes him 2/3 of an hour. A 2/3 of an hour is 40 minutes, because a third of an hour is 20 minutes. So it takes him 40 minutes to drive to work at 50 miles an hour, which means on the way back, it must take him 50 minutes to go from work to home, driving at 40 miles an hour. So we're going to verify this thing in a second. I need the room again, so we're going to erase everything. We're going to verify it. Okay, I need the room. Where can you put it? Let's do the verification right here. Oh, let's put it on the top. Two-thirds of an hour at 50 miles an hour. Implies a distance of 2/3 times 50, which is 100 over 3. Voila, there is your answer. $33 1/3. Question was, how far does it drive? The answer is 33 1/3. On the way back, he has how much time? How much time does it take him to drive on the way back? Which is total of 1.5 hours. Total of 1.5 hours minus the amount of time that he already took. This many hours at 40 miles per hour. Let's verify that thing. And that number this number better also come out to be 33 1/3 miles, because the road does not shrink, nor does it expand on its way back. Let's verify it. 1.5 is same as 3/2 minus 2/3, which is 6. 9 minus 4, which is 5/6. 5/6 of an hour at 40 miles an hour. As you can see again, the hours cancel out. The hours cancel out. 40 goes into 2 times, this becomes 3. Again, 5 times 20 is 5 times 20 gives you 100. And this is your 3 right here. And there is your miles. 100/3 miles. 100/3 miles is what we found here. The answer is he drives 33 1/3 miles on the way to work and on the way back home. 33 1/3 miles. That's it. This actually became a little bit more nitty-gritty than I expected it to be. That's okay. Of course I can always not post this video and just delete it, but if you're watching it, that means I decided not to delete it, obviously. I hope you got something out of it. I hope you learned something. If nothing else, at least you understand the pitfalls and the mistakes where one can make very easily if one is being careless, because a couple of times I made those mistakes myself. Remember here, instead of doing 1.5 minus t, I did 1 minus t. That was very careless of me. And then I made one more mistake somewhere else, I don't remember. But just why you have to slow down, and that's why you verify at the end. Everything has to add up. Okay? And the way we verify is that the distance from home to work has to be the same distance as distance from work to home. If you wish to get hold of me for personal private tutoring, face-to-face tutoring, or tutoring over the internet via Skype, I do tutoring for math, for geometry, algebra, statistics, and of course I also tutor for GRE, GMAT, SAT, and TOEFL. Go to any of these website addresses and send me an email, or you can go to kashwaniprep.com and send me an email from there. Alright? Thanks.